Good evening, students. Today's session we are going to explore about the final control element. Okay, so final control element is the element which is connected between the controller and the process. Okay, so in the first unit we have been discussed about the process. Second, we have discussed about the controller, and now in the third unit we'll be exploring what is about the final control element. Okay, coming to the contents of the third unit. First one is current to pressure converter and followed by pneumatic and electric actuators. Okay, so we call the final control element as actuators. Okay, so as already I have discussed, the control signal is transferred to the process with the help of a final control element. Okay, so controller is nothing but which is going to monitor and physically alter the dynamic conditions of physically alter the operating conditions of the dynamic system, right? So when you want to physically alter the dynamic conditions, we go for an actuator. Okay, so actuators are the device capable of carrying the control signal from the controller to the process. Okay, and we'll be exploring about the valve positioner control valve. Okay, valve positioner is actually the control valve with the feedback. We define that as a valve positioner and characteristics of control valve. Okay, so actuators are also called as a control valves, right? And we'll be exploring about the inherent and installed characteristics of control valve, mathematical model of pneumatic control valve, valve body, commercial valve bodies, control valve sizing, cavitation and flashing. Coming to the first topic, which is current to pressure converter. Okay, so always we need to convert the current signal to a pressure signal. Okay, so because the control signal will be the always will be in the form of a it is going to give the current signal, and that current signal is going to convert into a pressure signal. Okay, the standard range of current signal is from 4 to 20 milliamps. It's converted to a pressure signal of 3 to 15 psi. The purpose is to translate the analog output from the control system into a precise repeatable pressure wall to the control. Okay, and coming to this working principle behind the current to pressure converter, it works on the principle of flapper nozzle arrangement. Okay, so here it is going to convert the analog signal, that is current signal, to a pneumatic pressure signal. Okay, so let us see what is this flapper nozzle arrangement, and always we need to go for a calibration of the setup, which is nothing but zero span adjustment. Okay, so let us see what is the principle behind the current to pressure converter. Okay, so coming to the flapper nozzle arrangement, this is a diagram representing the flapper nozzle arrangement. Whenever you give a pressure signal at the input, okay, so the supply pressure is given at the input. Okay, so this is the nozzle, and the top one is a flapper. Okay, so flapper is a rod which is free to move at the one end, and it is fixed at the other end. Okay, and if there will be a gap between the flapper and nozzle, and accordingly the supply pressure is converted into a signal pressure. This is a diagram representing the flapper nozzle arrangement. Okay, so the signal conversion from pressure to a mechanical motion is provided via the flapper nozzle arrangement. Okay, so here the supply pressure of 20 psi is given at the input through the restriction. The nozzle is open at one end where the gap exists between the nozzle and flapper, and air escapes in this region. If flapper moves down, flapper is nothing but the rod which is attached above the nozzle. Okay, so if a flapper moves down and closes the nozzle, so that there is no leakage, and supply pressure will rise to the signal pressure. As a flapper moves away, there will be a gap and there will be a loss of pressure. Okay, so in the form of a gas. So finally, when the flapper is far away, the pressure will stabilize at some value determined by the maximum leak. Okay, so this is a graph representing the relation between the gap distance and the supply pressure. As there is an increase in the gap pressure, there will be a decrease in the supply pressure. Okay, it is inversely okay, yeah, it is inversely proportional. Okay. Mm, Okay, so the logic behind the current to pressure converter is the current signal 4 to 20 milliamps is converted into a pressure signal of 20 psi, 3 to 15 psi. Okay, supply pressure is 20 psi, your signal pressure will be 3 to 15 psi. You can see at the right hand side the current signal, and the bottom left hand side you can see the pressure signal, which is of 3 to 15 PSI. There are many designs for this converter, but the basic principle is always using the nozzle flapper arrangement. Okay, so here the coil, electromatic coil is energized. Okay, so when the current is given, the coil is energized and it makes the spring to which is attached to the flapper to bring the flapper closer to the nozzle, and the supply pressure is equal to the signal pressure. Okay, if there is a the current is not energized, okay, and the respective spring is going to elongate, which makes the flapper to move upward, and thereby the supply pressure is going to get leakage, and accordingly you will get the pressure signal. In this way it is going to convert the current signal to a pressure signal. Okay, and next one is a pressure gauge. Okay, so pressure gauge is an instrument used for measuring the condition of the fluid, that is either a liquid or a gas. Okay, so gauge is nothing but which is going to measure the pressure. Okay, so pressure is measured using the three devices, that is diaphragm, bellow and Bourdon tube. Okay, so coming to the diaphragm may be in different forms. It may be in the form of thin plate, it may be in the form of membrane, it may be in the form of corrugated diaphragm. Okay, here when there is an increase in the pressure, there will be a displacement in the diaphragm. Okay, so this is the concept behind the diaphragm. And coming to the bellow is there are number of convolution from the soft material. One end is fixed where air can go through the port, other end is free to move. Okay, so here coming to the next one is a Bourdon tube. It is a C-shaped hollow tube whose one end is fixed. It is connected to the pressure taping. The other end is free. Okay, so whenever there is a increase in the pressure, accordingly you can see there will be a gauge meet the gauge scale is going to deflect. Okay, with this will the pressure measuring instrument is discussed. Thank you.